Hi guys, I hope you're good since last video. I see that the introduction to powerful Helm chart went well. We are going to keep it up in this video and use our own values.yaml file. We will use Helm to learn about monitoring in Kubernetes. In this video we are going to see DaemonSets of our own and the monitoring system Prometheus ones connected to Grafana for the dashboard. We will be playing with it. It will be amazing. Those topics are now part of the new 2025 Kubernetes certification. So this video and the next will be super cool. I've left a link in the bio for the students who want to learn AI by doing, beginner devs who want to think at a service they could offer, or business owners who want to learn AI by themselves. It is free. There is a guide PDF to download and the video. Link is in the pinned comment on the video description. Get it now from our hub. Check our houses. Also, please like and subscribe. Thank you for your support. Open your terminal. Let's get started. DaemonSets, the diagram part. So for here we will need a diagram. So we will have a daemon set. We could use affinity to have it in selected nodes, but here we're just going to deploy it normally, so it's going to be deployed in all the nodes that we have in our cluster. So we have 3 different nodes available, 2 worker nodes and 1 controller. It will be write an HTML file at a certain path, which is host path, will be used as a volume. So in each node, DaemonSets are going to be doing this job of writing it. We'll get a pod randomly scheduled. Here, example in node 1, it has a label, containers, shared volume to the Nginx HTML page, so we will be able to display the page. So wherever this pod is scheduled, thanks to those DaemonSets, it will be able to access to this volume. We have a service. We use node port. A node port means that we can access from any port, from any nodes on that given port. It will be available. We'll be able to read it. In the user side internet browser, the user will be able to read the little sentence that you have about it. Okay. So we're focusing on that, and later on I'll be more going into the details of all the other things that you haven't seen in this diagram. So just here focus on DaemonSets, host path, the pod will be scheduled in any node, and we'll be having a service of type node port, and the user will be able to see the HTML page. So priority class resource. So let's create a priority class. So it's like a puzzle. We're going to create different parts. We're going to interconnect those parts. So important priority class. That's how we call it. So you can set different priority classes, having different values, giving a priority in the scheduling or not. So scheduling KTS IO, that's the API version. The kind is a priority class. The metadata, the name is medium powered priority class. The preemption policy is never. The value is 100,000. Global default false. I'll be writing more comments to explain the different parts. The description. This priority class is for medium priority pods only. Don't use frequently, just for once, for maintenance, to the above normal pod ones. Okay, so here we have the kind. Priority of pod is a priority class. The metadata name, so pod would refer to this field to select this priority class using priority class name. So on the pod side, we will have the priority class name to select this one, for example. So preemption policy never. This means never that this pod even if having higher priority of scheduling, it will never take down some of the pods. It will stay in the queue and wait for resources to be made available and not to preempt the other ones. So not take the advantage of his priority over the resources in the scheduling queue. It's not going to push everyone and pass in front. He has his priority, but he's going to be just waiting for resources to be available. Otherwise, this could take advantage. So it could preempt, it could just, based on the value, take the advantage on the other pods, because a normal pod is of value 0. But this value can be, I'm going to give you here the range. So this is the value that is by default 0. But you can set it up as an administrator. So you can manage those priorities of scheduling. After this number, you need to go into the documentation. 1 billion is the maximum. Okay. And after, you have also the global default. So just to see, I just write here, see documentation of Kubernetes as only explaining this. Can be a full video itself, because there's a lot of rules, a lot of ifs, elif and else. So just tell yourself that you are setting some examples of priority classes, so that DaemonSets, what is the topic of the video, so those DaemonSets, they have access to those classes to take advantage of the other workload pods, services. We want those DaemonSets to be always available in those nodes, to not have any other pod making those evicted or something like that. That's why we put that. And the global default, this is set as a default for all deployed pods. So only one priority class can have the default to true, but by default all the pods, they have a 0 value. We just keep it like that. We're going to keep it global default to false, and here in the description you can just write a message to describe, for example, when it is to be used. Okay, just for the other administrators or users that have access to those resource use, creating pods, for example. If they have this in their role, you can do that. I'm just going to copy it, change the name, get rid of the comments, and just change here the message, the description message. I'll be changing the value of the priority. This one we're going to call it Tokyo Junko Time Tracker priority class. We're going to give it a value of 500,000, and that's the one we're going to be using, just to show you that you can have several priority classes. So this priority class is very high priority one. Use it only for Junko Time Tracker. Okay, we save this. DaemonSet resource. So now let's create our DaemonSet. We're going to call it Daemon Junko Time Tracker. API version apps/v1 kind DaemonSet. The metadata, just let's go here. We'll create one pod representing what we will be describing in this file, okay, this manifest in each node. Okay, so here DaemonSets will be just created everywhere in the cluster, but you could use, here you can see, node affinity, but I won't be using any node affinity. But if you use node affinity, and maybe, I don't know, you have 1000 nodes, you want this DaemonSet to work only in 200 nodes, because those nodes, they're special, so they have special labels. At this time, you can target this DaemonSet to work on those ones, or to supervise on those ones, and use this affinity. The namespace, we're going to put it on the kube system namespace. The label K8S app, I'm going to call it Junko Tracker Daemon. After in the spec, we have a selector. We're going to match the label, the name Junko tier, Junko time tracker Daemon. And after in the template part, we have a label inside. So this selector here that you have created in the spec, okay, match label, have to be the same as the one that we described just under in the template part, in the template metadata labels name. So it has to be the same. So this one is selecting that one actually. Okay, same but not different. And here we go for the spec. Just let me go here and check the priority class. You take the name of the priority class that you want to use, because we're going to be using the field that I told you that we need to use in the pod. So here we're going to be just using a spec, which is a spec of a pod inside the DaemonSet. So the high priority class for preemption, advantage over the other pods, priority class name. So that will be the keyword that you use here, and you put the name, which is, just let me get rid of this. So we have the same name in both. Tokyo Junko Time Tracker priority class, very high priority. So this DaemonSet has a value, this pod of 500,000, so it will be the scheduler will understand that is a very high priority one and make it available all the time, and put it in his calculations of scheduling the other pods, in resources availability also. So the container here, we're going to call it Junko Time Tracker. I just use a light image, and I need bash this time inside the node, inside the container. So bash is not available in BusyBox. You have a sh. So we are writing here a command to an index.html page, as we did in the previous videos. Very nice way to show an example, which will be written in the shared volume folder. Okay, I'm going to use here, you can write it this way, in the list way, as I told you that in the previous video, but I didn't show you. Or you can write it, the commands like that, one after the other. This is also a list in YAML. So bin bash C, the option. After you can enter your command, C for command. And after here, we're going to be transforming this DaemonSet in a kind of a cron, because we've seen cron jobs. So I'm going to use here a bash script that is going to be doing this job of writing to a file in a certain frequency, like a cron job. So here we go, while true, we put the colors. It's like a list. Just let me here show you what I want to do. Whatever you put in the command is the same, that's what you would have put here in the terminal. So sometimes in NeoVim I don't see my cursor, I don't know why. So now I can't see it, I have to guess where it is. So while true, semicolon, we put the colors, do, and after we add an echo at the end, and we want it to echo the colors, but we want to choose a random color part of this kind of array list. We interpolate the colors. It's going to choose a random color. But I think there is something that I've forgotten. Random, yellow, green, division by 0, error token. Okay, so here we are missing, I'm just going to try to find here. Here is my cursor. We need the little dash here. And after you see, you get the colors coming one after the other in a random way. So that's how we're going to be able to have the HTML page changing color in a dynamic way. So I'm just going to copy this. As now I'm sure that it works. And I'm going to open the YAML file where we were before, the DaemonSets one, just with nano. Not going to bother. And after here we're going to go and put it in our little message. Do echo. And here we can put the style. You can use the same that we have used in the previous video. Add some more styles if you want. Just put semicolons between those. And after you put your justify content and just put a color. So there's no container or box, so it's not gonna look amazing, but at least it's gonna be centered. So a little dash here that I've forgotten before, the at inside, and we close with a semicolon. And after you can enter just a sentence. Junko will be at Hachiko on, and here also we can use a dynamic way to write the dates. I'm just going to use the same way that we used maybe the date, and we're just going to awk it. We're going to write it to the temp folder in a folder called Junko timing, and inside there will be an index.html file. And after we're going to sleep for 2 seconds, so this is going to run every 2 seconds. Every 2 seconds the color is going to change. So for the date here I'll show you. You see how the date is displayed. So here it's in European. So date, I'm going to be piping that with an awk command. Put print $2 and 4, second, fifth colon, and you see different parts are displayed. The first column. So that's how we adapt it. So, but I will adapt it to Bash in English. So there is not only Bash and SH, but there is also the time, how it is displayed. So here the columns are just going to be a little bit different than what I did in the terminal, but it's going to be okay. So it's going to be date, you print the second and third column. And here you're gonna just print, I think, the fifth column, print fourth column. Okay, so we are done with this command. It's good to explain a little bit because I haven't explained in the previous video, so we're spreading that through several videos to make sure you watch everything. Resources, requests, memory. So let's use a concept that we've seen before. So we can limit those resources consumed. As we will get a lot of stuff running in my little cluster, I need to limit those resources so that I can get everything running fine. Resources, requests, memory 100 MI, CPU 100 M. So in the resources video, I had prepared something to explain the MI and the M, how it is calculated, base 10, base 2, but I didn't put it in the video. So I think I'm gonna just write a little text explaining it and post it into the community area, RLC. So now we have created the volume mount. So this you've seen it now, you're expert on it. Shared volume. Okay, so at the same location where Nginx is going to be able to get this index.html. So our command is writing it here. So we're going to do the mount pass, TMP, Junko, timing, and after here optional, just to show that this can have platters of options, so you need to go into the documentation. Termination, grace period, seconds, I put 15 seconds. So you can also add some extra options like that. And after we go with the volumes, shared volume. And this time I'll be using the option that I have commented out in previous video, which is called directory or create, because we want to make sure that this DaemonSet, if the directory doesn't exist, because we know TMP exists, but Junko timing doesn't exist, we have just invented it, it will be creating it automatically. So here, if the directory doesn't exist, it will be created automatically. So we need to deploy the DaemonSet first, and then the pod. Because we want, when the pod arrives, it sees that the volume is already there. Otherwise, it's going to be having some trouble starting. Going to get a lot of issues. Okay, so we have the labels, the match label, we have our container, inside we have our comment, we manage the resources, we created the volume connection, and we added the option directory or create. That's our DaemonSet. Now for the pod, so we're going through the diagram that we've done at the beginning of the video. We've done the DaemonSet, which will be deployed in all the different nodes. And now we're going to be creating a boilerplate of the pod and adding this volume that we need to be connected. So the pod will be deployed anywhere. The scheduler is just going to decide where it goes, but wherever it will be deployed, it will find a DaemonSet, and the DaemonSet will be writing into this host pass volume. So the pod is ensured to have access to this volume. Okay. So we're going to call it Junko time present reader. The image is Nginx. We dry run it. We put it in the output in a YAML file with underscores. Put Junko time reader, and we're just gonna enter into this pod. As usual, get rid of the different options that we don't need. Okay, so we put a name, Junko time present reader, that's how I'm going to call it. I'm going to add the label. So here all the labels will be important because they're going to be used by other abstractions, which are going to be selecting those labels to be connected to those resources. So here we must set a label so that it is ready for the part about monitoring later on the video. So just do it now. So everything works fine, hopefully. So you can create a pod without any label. It's okay, it's going to work. But here we need to have it labeled to make the discovery easy using those names, the natural DNS of Kubernetes. So the container is going to be named Shibuya Web Page Info, image is Nginx, chat volume, you already know now, user share Nginx HTML. Here also we're going to control the resources. So here we're going to be controlling all the resources because we don't, if I don't control it, I won't be able to put the full stack in my cluster. And I want to demonstrate it well. So we're going to just limit the CPU to 250 M and the memory to 150 MI. So whenever you see the I, just tell to yourself is a multiple of 1024 that you just multiply to get that number. I mean that units, while normally you just use thousands. So same here, must have the port exposed, the container port. Okay, this is for later in the video, as we need to name the ports. So we're going to use those names to be able to pull the metrics from this pod naturally. Must be maximum 15 characters. I've tried more and got an error, so don't try. I like to play with those names, but here we just have to keep it short. So the container port will be 80 and its name will be web page metrics. And after we just connect the volume. So here I'm putting a name on the port because I'm going to put a name on the service port also. And I'm going to use another abstraction. This is just an example that I want to show you later on. If you want to do custom monitoring to some pods that Prometheus doesn't have access to naturally, okay? I'll show you how to extend it through a service to be able to be discovered after you get a volume. So here, same here, I get a little bug with those lines. Going back to this pod, we have here the limitations, the volume, the path. I use also here directory or create, but I don't need to use it. But if you want, you can use it here if you want to deploy the pod before the daemon set. So at least for sure it's present. And you won't get any error because the pod will be able to create the folder Junko tracker. Okay, I'll stop here a little bit. Let's have a break. Please like and subscribe during the break if you're not subscribed yet. So 89% of people watching the video are not subscribed. So I suggest you to subscribe, like, or just like. Just give a nice signal to the algorithm. DaemonSets monitoring system, Helm Prometheus. So we're going to go back into this diagram, and now I'm going to show you the Helm side of it with those DaemonSets also for Prometheus. So here we have the admin, the SRE. He's used Helm to deploy Prometheus stack to the cluster and expose Grafana as well. He's using his our custom patch of values.yaml that we're going to create together later on. Let's write here very quickly. Expose services. Maybe resource control also. But this Helm stack is pretty heavy. And after here we have DaemonSets, which export metrics. So DaemonSet means they're present in every single node, and they can scrap, they can get those metrics, send those metrics wherever this Prometheus deployment is scheduled. So it's randomly scheduled here, for example, in node 2. It collects and stores those metrics. And after Grafana, I can plug in to that. The deployment Grafana is same, is randomly scheduled. And after here, we can expose those services, those components, deployments using node port, so that we can see in our dashboard, Grafana dashboard, we can check directly. I'll be showing also Prometheus. I'll be exposing Prometheus just to show how it looks like and how Grafana is better to just plug it in so that you can have nice displays, easier to read. After here, that's the extra of this video. The pod, we put a label, we put a name on those containers. Okay. The numbers will be different in the video, but there is a selector in the service which is going to target the label of the pod. That's how it's going to be able to connect to it. Okay, and the service itself has a label. It has the container. It has the name of the containers. Okay, and this label is going to be selected by what is called a service monitor. Okay, which is supported by Helm. So in the cluster, if you have this service monitor, you can connect service monitor to be able to scrap the pod metrics. So the daemon set has access to those metrics and can export those to the deployment wherever it is of Prometheus, so that you can see those in Grafana, okay, in your dashboard. So that was a little bonus for people who stayed to this part. You got this little trick to be able to scrap your pods which are not tracked by Prometheus. So let's deploy this to the cluster. So as usual, if there's any issue, we can try to fix it. So here I'm back into the DaemonSet file. I'm just going to fix it a little bit. There are some little errors. I'm just going to go down to the command. Overcomplicating for sure is going to create errors. And here I'm gonna go to here. No. Where is it? Shot volumes. Let me check. I think it's in the command. So first, let's fix the indentation. Okay, this is better. Okay, so we have those here, we have the container, the resources, let me get back in, something wrong. Okay, so there were an error with the equal. Just change this. This should be a column. DaemonSets, priority classes, the pod. Okay, we have everything. So we're going to use this priority class. This one we're not going to use it. I've commented it. But it will be deployed. So you'll get 2. Let's apply it to the cluster. Let's get the priority classes from the cluster. As you can see, they're deployed. There is some other ones. So just for the priority classes, for the naming of it, do not use the prefix system dash, as it is reserved for Kubernetes system. And as you can see, it has a super high priority value. So here the DaemonSet, I'm not sure about the indentation, but still, we're going to try. If there's an error, we're going to come and fix it. Tokyo Junko time tracker priority. So that's where we're going to be referencing that. We apply it to the cluster. Okay, it's good. So the indentation was good. I did fix it. We get the DaemonSets. Nothing, because it's in the kubesystem namespace. And here we can see they're all ready. 3333. I didn't put any node selector, so it's going to be in all the different nodes. In my little cluster, the controller node accepts those pods to be scheduled also. And here we can see Junko timing has been created. Also the file, and we can see here, you see the equal. So I didn't change the right at the right place. I didn't change it. So daemon, let's go back into this comment. I knew there was something wrong. The equal is in color, not in style. that I need to change it. So let's change it. After, we're just going to reapply it. So here we go back. We change the style, equal. We go to the color, because we took it from the terminal where we put equal and we just paste it here. So it doesn't work like that. I have to adapt it. It's HTML. We reconfigure it, so we reapply. It will be like a patch of it. We might need to describe it just to make sure it's fine, if we see the same line or not inside. So described DaemonSets kube system, and here, yes, we got it right. So now this is fixed. It has created the Junko timing folder, as we can see here. So here I'm in the controller node, and as you can see, it changes color every 2 seconds. I'm going to go in node 1, just SSH, to show you that it has been created also in here. And I'm going to SSH in node 2. So that's a way to see what's a DaemonSets. So here's doing the same job. It has been deployed in all nodes. And now we got the pod. We got a pod having this volume. This volume is connected to TMP Junko timing. So it will find it there, because the DaemonSet is already working every 2 seconds, changing that file. The pod has been deployed. We get the pod. It will be ready very quickly. We just wait a few seconds. Okay, 12 seconds. Only 15 seconds and it's fine. No, it's not fine. I just describe it to see if everything is okay. Yes, it's just taking more time. That's it. Yeah, now it's running. Now we're going to expose the pod by creating a service called Junko Time Present Reader. Expose the pod Junko Time Present Reader. The port 80. The target port 80, the type not port. So this is going to create this selector. Not port. We got the port 32,585. I don't know if my browser is slow or not, as usual. But we'll be able normally to see that page. So we are on node 2. Okay, it's running on node 2. But as we're using node port from the controller, I'll be able to access to it normally. Let's add a little localhost before that. And yes, we got it. And is it every 2 seconds changing? Yes, it's changing every 2 seconds. So the DaemonSet works well with this example. We use it like that. This is our little demo. And later on we will be seeing the DaemonSet, the serious ones, doing some monitoring in the system. So we could add affinity in the DaemonSet, as I told you, to have it running in fewer nodes and have the same affinity in the pod, so that they can meet at the same place and have the pod access to that volume. Okay, so for that you can use labels representing a stack or kind of pods, say for example GPUs for your AI applications. Demo custom pod metrics made available for scrapping. So I showed you the bonus into the diagram. Now what I'm going to do, I'm just going to do the YAML files to show you how they're connected to make this happen. So you have a pod, special pod. You want the metrics to be scrapped by Prometheus. How do you expose this to Prometheus? Node exporter. So first, service to pod. You need to create a service. So I've copied the label from the pod. I'm going to go into the service. You see, I've used before kubectl expose. So the service has been exposed, but here we're going to create a custom one. Okay, so you create your service, API version 1, kind service, the metadata, the name, Junko Time Reader App Service. That's the name of it. So I just used the same name as the other one, but I add service to it to make it easy. And that will be the label of this service. And this label of the service will be used by the abstraction, the other intermediary resource that we're going to create, that is going to make the link between Prometheus and this service. And that's how Prometheus will be able to scrap the metrics from your pod, and you'll be able to monitor the pod by plugging Grafana into Prometheus. Okay, so label for the other resource that we are going to create called the service monitor, that will have a selector targeting this label. The service monitor is supported by Helm, monitoring Prometheus metrics. Scrapper. Okay, so we have our app, our label here called app, Junko Time Reader, app service, and after here the spec selector to target the pod labels. So we put our selector, and that's how we target Junko Time Reader app, which is the pod. Now this service knows the name, the selector behind it, so it can connect to it. Target container port exposed at pod level with naming enable. So now we can use the names. This name, web metrics, is the name that you have used in the pod. The port here, 80, is the port, the service port. And the backend pod that we are targeting, that we want to scrap infos from, is the one exposed port, is the target port. Okay, because you can be confused with this port, target port. Now the service monitor connect to the service, which was already connected to the pod. So I'll put it this way so that you see how they are intertwined. Some service monitor, Junko Time Reader app.yaml. And that is the one that is going to help you to make the link. This resource, which is an API version monitoring.coreos.com/v1. The kind is a service monitor. The metadata name is Junko Time Reader app. Here I add service monitor. The label, I'm going to use the release name. So at this time, later on, we will be deploying Prometheus through Helm. That Helm has a release name. So to be able to be connected to that, because Helm supports this resource called service monitor, we need to use the label with a key release and with a value, the name of the release that you have chosen. Okay, it's arbitrary. That's why I put Tokyo Mangakisa monitoring, so you know it's not Kubernetes. If there is anything Japanese Tokyo, that means it's something that you can custom. That's why I'm using those examples like that. So you know what is the core, what you need to use, and what is what you can customize and do whatever you want with it, as soon as your logic understands what you're doing. I mean, or if you understand what you're doing at least. Spec. Here, same as selector. That would reference the label of the backend target service. That's why here the match label, it's an app, Junko time reader app service, because this service monitor resource is targeting the service, and the service is targeting the pod. And the Helm release is targeting this label called the release Tokyo Mangakisa monitor. That's how the DaemonSet will be able to scrap those pod metrics. And now we need to map to those, if any, to those ports. And Prometheus would scrap metrics from that pod container. So here I could put port, web page metrics. I put here a number, but it's up to you to choose, depending on how much resource your cluster has. I'll put 2 seconds. Okay, let's now do some little bit of terminal talk. So Helm Prometheus stack has already its own service monitor. But here I just wanted to show you how to create your custom one, so that you get the logic of how the Prometheus DaemonSet works. How can it scrap your pods that are not tracked by it natively. Okay? So how do we go? Pod. The pod, there is a service, and after the service there is a service monitor. Service monitor, which is supported by Helm, can access the Helm Prometheus release. Prometheus release has a DaemonSet scrapper. That's how they will be connected. Okay, the pod with label and named ports. Service, same with label and same name ports. Okay, I don't see my cursor, but it's okay. I'm gonna be able to make it. And the service monitor with the Helm release name. Okay, the Prometheus stack release name has label. And it's going to be mapping to the port names also. Port names that you have put in the service, and the Prometheus DaemonSet will send data to Prometheus deployment, which will store those, and Grafana will be plugged in to get our dashboard display of those custom pods, special pods, call it the way you want. But that's how you're going to get it. Let's go and see the whole process of helming. So adding an affinity to pod for scheduling in beta nodes. Okay, so this one here is down. Let me get all the pods. So here we have the Junko container status. I'm just going to be checking what's going on. Stopping container, killing it. The node was low on resources, ephemeral storage threshold quantity available. Yeah, that shows you the problem of volumes, and be careful with volumes. So you need to limit those using ephemeral storage, for example, as we've seen in previous videos. But here our DaemonSets is just working. But my node is also very weak, my node 2. So my node 2, I don't have much resources. I need to pimp it a bit. So I'm just going to delete the pod. Let me go into the pod to create this affinity. So why do I do that? Because as I showed you here, I have some limited resources. So I'm just going to be scheduling this one, making sure it's in the node 1. So we had our affinity, node affinity, our magical long sentence required during scheduling, ignored during execution, not selector terms. We're going to match on the expressions. Key, we're just going to use the key location. The operator exists. That's it. If there's a key location, you can schedule it there. Normally I have only one node with the label. Let me see if so I'm just going to label it, node 1, label location Shibuya, has been labeled, not labeled. Maybe not labeled because it's already there. Yes, I've done it already before. So that's good, we're going to get it on node 1. We apply the pod and it's going to be scheduled where we want it to be. Yes, it's on node 1 and now it's running. All good. So this should be running. Yes, we are back to life. Now, GitHub. Helm Prometheus. Okay, we go into the GitHub to get this stack. This is the documentation. The README is not too long, that's what we like. But there is no warranty that it's gonna work. Okay, it's open source. And after here, you get this command, which is going to be deploying the Helm chart. Helm Prometheus stack. So instead of deploying directly, what we can do, we have already installed the Helm in the previous videos. So we get the repo. That's what we did now. That's what we're gonna do. I mean, we just took the link, but I'm gonna be, it can be applied directly or downloaded locally and then untarred and then customized. And that's what we are going to do. Okay. So that's the link. This one already exists. Adding the repo. So I already done that before. That's why it says already exists with the same configuration. But you need to enter the command that you've seen in Git. After you can use here this command because you haven't seen it yet. Helm pull. And after you put Prometheus-community /Kubernetes Prometheus slash cube Prometheus stack. And now normally you're going to get a folder. So you see, you don't get the folder. You get the zipped file. So I'm going to delete the zip file. And after I'm going to use the option because we need to untar this zip file. Okay, this has been deleted. Here you add -- untar command. This option will help you to get the folder now. Perfect. That's what we want. Cube Prometheus stack. We go inside, and this is the Helm chart that you get. So this is not a boilerplate. It's a full Helm chart. We're going to the values.yaml, and this is a long file with some default values that you can override. So you can come here, get the part that you need, change it, and after from one deployment to another, you just change the values.yaml. That's what is amazing with Helm for your application. Okay, you variabilize, put those variables into the values.yaml. In your templates, you put a space to pull those values from that, and after you just change that. So in the templates, you see we have alert manager, exporter, we have here Prometheus. You see all the YAML files involved. That's why I told you that if you have a local cluster like mine, it might be overwhelming. That's why you need to manage the resources. Make sure that the resources are not is not going to be over-consuming. Even in production, you have to be careful. Or custom values.yaml file. Let's create one. So I said that I'm going to use a custom values.yaml just to expose Prometheus and Grafana deployments. But actually, seeing that, we are going also to limit the resources consumed. So I'm going to call it custom Prometheus stack Helm values. This file, your custom one, can live anywhere in your computer. You're just going to be referencing its path. So that is going to be taken into consideration. There is a lot of options that you can add. I just put this one here so you can see global, scrapped interval, evaluation, intervals. Just for it to not take much space on your computer. So default is 15 seconds, but you can increase it if you don't want to have too much stress on your cluster, meaning on your resources used. So the nodes, you don't want those nodes to be too much stress, but anyway, you will be able to refresh and change it from Grafana. So from Grafana, we just refresh when we want. So other custom is limitation of resources, as we have seen in previous videos. So what is good with Helm is that you can patch just using custom values.yaml. That's what we're doing now. So we go for Prometheus spec. So just like we've seen in pods. And that's how we're going to patch it. Resources, memory 200 M, CPU 50, limits, memory, I'm going to go 500, 250 for the 250 M for the limits. Same here, you have an extra option if needed. You can also set here the retention. Okay, how long do you wanna have those logs? I just put 1 hour. You can put less even, because it's just for the time of the video. So this scrap interval 60 seconds also. So there is the global scrap interval, but you can do the Prometheus one. This option also that I'm going to put here, service monitoring, is for example, what I showed you, the bonus. Okay, if you want to make available the possibility to use service monitor of your own. So selecting the label that you have used, as I showed you, the release of Helm, so that you get the service monitor that can connect to the DaemonSets, not the exporter of Prometheus Helm. So here you need just to provide the service monitor selector in camel cases. Okay, and now we can expose the service to have access to it from our internet browser. So Prometheus here we're going to be exposing, and Grafana also as well. So what is nice is that when you expose this Prometheus, not the ports, you get this tutorial showing you how to get the password for Grafana. Service not port. If you don't choose a port, Kubernetes will choose one in the upper band. But as an admin, you just get if you want to choose a port, just choose one in the lower band as a convention. The range to determine upper and lower band of the ports available for not ports are between 30,000 and the 32,767. So the upper band 32,767 and a little bit under. This Kubernetes will give you ports around that, while you're going to set ports around 30,000. So we're going to go for 30,900. The node exporter, we're going to also limit this component request resources and limits. 100M, 50M for the CPU, and the 100M max for the CPU, and 200MI for the limits memory. So let's also expose ourselves Grafana. So Grafana, the service type not port, and the port will be 32,000 that we're going to choose. Let's go a little bit more in the lower band. Okay, so we have a global, we have set Prometheus, Grafana has a custom. Now install our chart to our cluster, monitoring on. Let's turn on this monitoring stack. If there's any error, we're going to fix it along the way. Helm install, that's the command. Before that, service monitor. I get here the name of the release that we have set so that it can be at least connected. We don't need it because the pod that we are deploying, actually this Helm can discover it, but at least you see the whole process. Helm install, I use the same name, Tokyo Mangakisa monitor, has the service monitor label, the release, so that they have the same, they can be connected. I put the folder cube Prometheus stack. I use the F flag for Prometheus for custom values.yaml called the custom Prometheus stack Helm values. Okay, so Helm install the name of the release, arbitrary name, it has to be the same in the service monitor. And after you provide the folder where is your Helm chart, and after you use the option F for your custom values.yaml, you can use namespace and after the create namespace. So namespace, you put your namespace, and create namespace. It's an option to create on the fly the namespace where you want it to be deployed. But here we don't indicate any namespace, so it's going to be deployed in the default namespace. But you have those options available also. We have everything set, the folder, the release name is matching. We have our values.yml. Let me open another tab. So I have pressed enter. I just wait until it comes to life. Takes time. Okay, that's why. There are some issues. Spec resource CPU, spec resource memory, unknown field. I don't see where is the error in this sentence, but I believe that I have forgotten. There's a, I don't know, indentation issue. So the release has failed. So it's not Helm delete. It's going to be Helm uninstall if you uninstall it. Here, resource requests. So I forgot the keyword, requests. And after the indentation is not good for the rest, we need to move it a bit in, like that. Now we're good. I check the other one. Yes, I got requests and limits. Should be fine now. Oh, it worked. Delete has been uninstalled. So now we can, actually you can use delete. Okay, so now there is nothing related to that, to the Tokyo Manga Kisa monitor. And now it's gone. Okay, it's gonna start everything, the whole stack. See how many pods are coming up. So you need to have those resources managed. Otherwise, it's gonna consume too much from your little local cluster. Because of my low resources, I mean in terms of compute and disk, this could have some issues on Node 2. Just to tell you that my Node 2 can have some issues, but it will be fine. It will work because you have those DaemonSets. So you see here, for example, one pod has been evicted. Evicted from Node 2. Yes. Problem. But if it is evicted, that means it's going to be rescheduled in another node having enough resources. So this will be fine. We don't need to track that. We can just check with the key top command. There's still space, still resources. Get Grafana secrets. So here you see we get a little tutorial after the validation of the deployment of the stack. Here. So there are different steps, but we are already exposing those ports through those services through our custom values.yml using the node port. So we just need this command here in the middle to get the password. Okay, there were my comments. Let me enter it now seriously. Prom operator. This will be the password. And the user is admin. It's just telling us get Grafana admin user password. So the user is admin. And prom operator will be the password. There's another way to get it if you don't get the tutorial here. You do kubectl or k if you have the alias get secrets. And after you describe the right secret, which is the name of your release, Tokyo Manga Kisa monitoring. So here there's a typo, but it's okay. Okay, here we go. And you get your secret here. But you can't see it with the describe. But you can see it with the edit. It's a base 64 encoded password. You see here, you get the admin password and the admin user. So you can just copy it from here after you exit. It's a Vim, so it's a escape :Q. And after here, I'm just going to show you how to decode it. So if you don't get that amazing tutorial, you can still get those passwords. Echo. And after you pipe it, and you go base 64, and you decode. So you use the D. The D key, and you see here prom password just behind there. The formatting is not looking very nice, but we got the password on the bottom left. And here same for the admin. You should see written admin after by piping it to base 64 with the option D decode, and we get the admin just before Creditizens controller. Alright, it's fine. So now let's get our services and see, is our node port given or not? Yes, so the custom node ports that we have chosen has been, so this was the one we have created, and that's the one here, 30,900, 30,900. So this is the Prometheus one. This is how it looks. But you'll see after with Grafana it would look better. And after here you can enter some queries. So you can actually use only that and do your query. You can go also to /metrics to see the raw metrics, which has been scrapped. That's how they are displayed. We can see Tokyo Manga Kisa down there, and some other ones, because everything is scrapped. Let's go to the 32,000 for Grafana. Amazing. Looks like it's working. We wait a bit. Computer is a bit slow. It's going to be charging the page. Yes, the page is here. Admin. And what was the password? Prom something. Yes, we got it. And now is the dashboard. Service Junko time reader. So after, if you want, you can deploy those custom service that I told you that we created for it to be available inside Prometheus, for it to be able to discover those. Our pod can be discovered by Prometheus without it, but yeah. You can also deploy those. That's why I'm just deploying it now, to show you that the service has been created, but it's a cluster IP, so it stays internal, it's not exposed, and Prometheus internally will be able to scrap it through the service monitor. And here, when we get the service monitors, that's the one we created here, and that's the one which will be the in between our pod and the node exporter. Okay, when we describe it, we see the release name is linked to the release. That's how we're going to be able to connect to it, to the port web page metrics of the pod, selecting the label of the service. So passing through the service that exposes that port for us, for our pod. Okay, so you've seen that at least in terms of example, and after we will be able to go into the Grafana dashboard. Here we go, we have a node exporters. Those are DaemonSets, that's why there are 3, because they're present in every single node. Controller node, node 1 and node 2. You see those 3 are present in the different nodes that you have in our cluster. And all of the rest has been evicted from node 2 and is present in node 1. Okay? Okay, Junko time present reader is still there. At least we have everything running fine, so we will be able to stress that and to see the changes. Grafana dashboard use. So on the top here, you click on dashboard. That's the easiest way to just go to the right one. You choose, for example, here the Prometheus one. And you see it starts already scrapping. Here you can change the intervals. Last 5 minutes. Refresh, you see, every 60 seconds. That's what we have set. But we will be able to change it, going more fine-grained vision of this dashboard. But now we just go in another view like that. Okay, we go back to dashboard and we can select something a little bit more precise. Okay, Grafana, there's nothing. Let me go back. For sure there's nothing because the metrics are pulled from Prometheus, scheduler, persistent volumes, the pods, networking, the different components like the controller. Here you can see different namespaces. You can also access to it from here. The bandwidth, read write. Here I just did a cut-up to see how is the pod, the one that we have created at the beginning, the Junko reader, Junko time reader. Here we can see alert manager. We can change the namespace here, the kube system namespace. After maybe we can try to find this pod, namespace and pods. This is better, and here we get all the pods present in the namespace kube system. Pretty amazing. Kube system. We might need to go in our default namespace. That's where we have our pod. And we can see what consumes more and less, and how much. Junko time present. The memory usage. Here we can change it to every 5 minutes, so the graph looks a little bit better. We can change here to 5 seconds, so it's going to be pulling metrics every 5 seconds. As I told you, from the dashboard we can change that. So we go like that as an overview of everything, and after we're going to be making some special commands to stress it a bit. Here we have the storage I/O, nice table, so it's showing us the throughput, read and writes, the rate transmitted, the packets, receive packets rate, the bandwidth of transmission and reception. Okay, the quotas, the quota reader. This, you see, we can see the quotas that we have set. The request is equal to the limit. It wasn't when I did create that pod. CPU request. So here we can see with KTop, we have memory at 13 MI, CPU at 1 M. Okay, is it the same here? Junko time present. The CPU is not at 1, it's not at 1, it's at 0.002, which is expected because it's doing nothing. So we can see that CPU is not very precise with KTop, while here is going to be very precise with the Grafana dashboard and Prometheus pulling those data. But here we can see 13.8 MIB, almost 14 for the memory usage. So this is very close to what KTop is showing us with 13 MI. So let's go in our pod and stress it a bit. Okay, won't leave it alone like that. It's not doing much. Let's make it work a bit so we can see how the graph is going to move in this dashboard, because it's been just a few minutes that we have it running, so we don't get those nice waves. Let's create those artificially. We're going to use our DD command to do the stress. We might maybe write a file first and see how it goes with that. So you just pause the video to get those comments. We're going to write to tmp stress w.txt bs. I'm going to put a 30m. And the number of zeros, so 30 megabytes. It's actually MI, it's not M. Okay. So it's not true. What it is again? If dev 0 off, maybe. Help. I'm just going to go into the help and check. Yes, if off. Let me change this. Okay, so the command has been sent. Do on top on the nodes. It's not moving much. Here we have on the pod the CPUs and the memory has increased 163%. Okay, let me refresh the page. Okay, so let's go every 5 minutes, every 5 seconds. This is good, but we can see that it has started increasing. Even if it is a CPU rewriting on memory, but everything passed through the kernel, so CPU is going to work. the transmission bandwidth, the throughput. Yes, you see, ooh, it goes just read writes. That's what we have triggered. Let's put 100 times and see. It should just keep going up. Six megabytes per second. Throughput 12, 13 megabytes per second. Just keep going up. Okay, 500 MI. $33 on usage. And now it's going down. Because here we're in the CPU side. We have used the resources to do the read-write. Now it just keep going up in here for sure. Hasn't pulled all the metrics yet. Let's now stress the the CPU maybe. Let me just do this. We will stress the CPU now, but even that will use some memory for sure. Okay, there's the user space, kernel space. It's gonna go down there. It's gonna go back up, get back down. DD if dev0 off dev null, and here we're just gonna be just going 100 M. So we reach the gigabytes very quickly. We should see the key top start rising, but it will be throttled. Don't forget. We have put limits in our pods. You can't play crazy for a while. Just a little bit. 115 M. Okay, this is moving. And CPU is in the first part. I scroll down. That's the one we want. Okay, this I don't get it. Not yet, we have to wait. The memory, 79% of the limits. The CPU quota, 34% request, CPU limit. So the CPU usage has augmented. Okay, so this means has been throttled. You see? Now it's flat. It's flat for the memory usage. So the memory limit is 150, the CPU 250. Okay? But here we see 120. So there is something using resources other than the pod itself. Let me get back in and we exit. Good. So we have stressed that in different ways. Let's see the stress command with the command we have used here, just to show that even when you stress CPU, your memory is going to be also stressed somehow. You're going to be using some. Let's go for just a little sample of 1M. We're going to be checking on the read-writes only. Otherwise, the output is going to be huge, and I'm not able to read everything. I don't understand everything. But at least here, anybody can understand the option eTrace. I'm going to stop the count to 1. Okay, good. So here you see it goes is read, write to an address, writes, reads, local name alias space, reads again, writes to the records. So the memory is involved in this CPU stress method. Okay. So I think we've been around the different topics that we wanted to see. So the K-top has been decreased. Everything is down. We have stopped stressing it. Let's refresh one more time this page so that we can see everything coming back down slowly. Okay, we are back at 13M, 18 MIBs. We can see those bandwidths, transmission, everything's going back down. It's cooling down slowly. Yes. What about the cube system? It's pretty flat there. We can check the DaemonSets in the cube system. That's why I went there. Junko Time Tracker Daemon, one of those, has some job to do. And after the job is done, so every 2 seconds it's going to be writing. So maybe we can go and check the read-writes of these DaemonSets here. Okay. And the same IOPS. IOPS doesn't move. That's normal. But the throughput is going to be moving. So we didn't even need to plug anything because the stack has deployed everything underneath for us. Here we can see the line showing the throttle. So you can also go into the pod itself, have its own metrics. This is the DaemonSet. Hasn't been stressed much, but in the default namespace. Where is it? Here. Here we get the pod, and here we can see the stressing period that we have engaged. I put every 15 minutes. And we can see how the maximum CPU here is at 0.25, which is a 250M. And here 150 for the max for the memory. And we can see the different, just isolating this pod and seeing all the metrics for it. On our experiment, how it went up and down slowly, and after down abruptly. Tear everything down. Do not forget the volumes, very important. We didn't set any limits on those volumes. When Helm is going to uninstall the stack, just list it first. Okay, we get this name. So when we're going to now uninstall it, it's not going to touch at the physical volumes in those nodes. So we will need to go and clean up those. You might need to create a script for that. So even run Helm using that script. So in the logic, it's going to uninstall, and after it's going to go and do this kind of cron job of cleaning. Okay, we delete the service monitor that you have deployed, the custom service also that you have deployed. You need to check everything. You still work locally here because you want to see how it works. But if you are in a cloud provider, this means money. You'll be paying if you forget any resource. Okay, and now we're going to be clearing out those folders in the TMP. I'm going to SSH to every single node, node 1, and after I'm going to go also in node 2, and I'm going to get rid of TMP Junko timing. So I'm getting back all my resources. And if I'm in the cloud, I don't pay for any storage or for any networking to the storage. Okay. Got all the pods back to what we got initially. Okay, I need to delete a service still. But this was a service that I have exposed myself, so it's not handled by Helm. But the full Helm stack has been just offloaded. We have seen how DaemonSets helps to have pods running in the different nodes in a duplicated way, perfect for monitoring when needing to pull metrics from different services and pods, fine-grained control over your master art application deployment and infrastructure setup. We have seen Grafana on the dashboard, use our own pods to see changes in monitoring observations. We have used our first custom values.yml file in Helm. I suggest you to go through the Helm documentation and pick what you need from there. In the next video, I'll be again using Helm, but this time we'll be using our own custom fields and see also another super important feature of Kubernetes newly introduced in the 2025 exam. Okay, let's stop here. Hope that you like this video. Please like and subscribe, and see you next time.